I was thinking of several puzzling pieces of knowledge science has, and made this video to share a few thoughts. They will explain the experiments at the end. The first puzzle piece is the Large Hadron Collider. The 27-kilometer underground particle accelerator works by accelerating streams of charged particles as close to the speed of light as we can, and then recording the debris of the collisions. After the public's fears of the scientists inadvertently creating a black hole were relieved, the LHC went on to discover the Higgs boson. However, I believe there is still an unintentional byproduct. Subatomic particles must be observed indirectly. A particle like the Higgs decays before it can reach the sensors lining the detector. When it decays, it emits two high-energy photons. With the help of E equals mc squared, scientists figure out the mass of the particle the photons came from. This is a simplified explanation, but it specifically highlights the point of my question. According to the standard model of particle physics, photons are the force-carrying particle for the electromagnetic force. So, what if the LHC is actually witnessing the electromagnetic force being ripped from matter? Particles normally react to the electromagnetic force, strong nuclear force, and the weak nuclear force. Neutrinos are known to only react to one of them, the weak force, and are also nearly impossible to detect. The byproduct of the LHC collisions are particles missing the electromagnetic force and now just react to only two forces, the strong force and the weak force. The strong force is strong enough to hold together particles of like charges in the nucleus. It is also responsible for the mass of matter. These two-force particles are created every 25 nanoseconds while the LHC is running. This stockpile of unintended material doesn't have to be dumped because it doesn't react to light or anything else still containing the electromagnetic force. On a galactic scale, matter with these characteristics is called dark matter. The very same phenomenon that has astronomers staring at the sky is a mere byproduct for particle physicists underground. However, the LHC isn't the only experiment scientists unknowingly work with dark matter. Another puzzle piece is the infamous double-slit experiment. This experiment demonstrates that when small parts of matter are shot through two slits, a wave pattern will form on the other side. Even when particles are shot one at a time, they create a wave pattern. The explanation of this phenomenon was clear as of September 2017. Then, two different laser interferometers detected the energy of colliding black holes. An event over 1 billion light-years away had a physical effect on physical matter on our planet. No matter how intangible the term space and time may seem, a wave needs a physical medium to travel in. If space-time is that medium, then it must be a physical thing too. It can't be seen, but it can definitely be felt and measured. Space-time, two force particles, and dark matter. They're all puzzle pieces that fit perfectly together to make the same space that fills this space in between everything we can observe. The double-slit experiment is a kind of electron microscope to see the texture of this matter. It's like the wave-like patterns that develop in the sand when the tide goes out. I can effortlessly leave footprints in the beach while running to the water, but an ant taking the same path would have to travel up and down each crest and valley along the way. The ant doesn't decide to walk like a wave. The terrain dictates it. This terrain isn't the same flat sheet warped by a bowling ball to illustrate gravity wells, but an ocean of two-force particles. This two-force matter is repelled by three-force matter, creating bubbles of less dense two-force matter. In the case of black holes, the extreme mass repels all dark matter. Light entering the event horizon is like a fish swimming into a bubble of air. With nothing to travel in or propel against, the fish is stuck. Einstein described gravity as the warping of space-time. The mechanism of that warping is the repulsion of dark matter by regular matter. It is that repulsion that is the actual force, and gravity as we observe it is just a side effect of it. But gravity wouldn't exist if only particle accelerators made two-force particles. Hungarian researchers found that 1 out of every 100 decaying beryllium-8 atoms produces a strange particle they've called X17. The X17 particle decayed quickly, leaving behind two high-energy photons. This puzzle piece illustrates how gravity was born. After the Big Bang, the universe was a dense soup of gases. It took thousands of years for it to clear up so light could shine. It was during this time that enough regular matter decayed to create enough dark matter to begin the process of gravity. The more matter decayed, the more two-force particles were present, and the more the repulsion became a factor in the universe. Gravity is a part of the life cycle of matter. Richard Feynman said in a Caltech lecture, "It doesn't matter how beautiful your theory is, it doesn't matter how smart you are, if it doesn't agree with experiment, it's wrong." At first I thought running the double-slit experiment alongside the LHC while it was running would illustrate this theory. The newly formed dark matter particles would interfere with wave pattern 40 million times per second, hopefully obliterating it or leaving some other visible evidence. However, regular three-force particles would do the same, and that would only prove an ocean of spacetime particles. The X-17 particle experiments bring a new option. The report states that 1 in every 100 times an atom decays, a particle 30 times more massive than an electron is ejected at a specific angle. Is it possible to place a double-slit experiment at that angle and have dark matter interact directly with dark matter? The double-slit experiment was humanity's first experience with dark matter. And if this life cycle of matter theory is correct, it may still help us probe its properties. If you have any information on this experiment near the LHC, please respond to this video. And thank you for watching.